On pages 9 through 12 of our Unit 4 notes, we're looking at the idea of a function. A function is a relation in which each input, or x, or independent variable, has exactly one output, or y, or dependent variable. This picture up at the top of the function machine is a really common representation of this idea. We have our input x that goes into the function machine. Inside the function machine, something predictable happens, that we have a consistent and predictable output y. Given an input x, we know exactly what to expect for our y. So one output for a given input. Looking at these non-math examples, for each input, we have exactly one output. So given an input of city, the function being what state is this city in, we have one output for each of our inputs. So input of Seattle, question, what state? Always Washington. Input San Diego, what state? Output, always California. Input Bothell, what state? Washington. So it's not sometimes the case that Bothel's in Washington, sometimes California. So it's okay that more than one input go to the same output. What's important is this one arrow leading from each input. Seattle always goes to Washington. San Diego always goes to California. Bothell always goes to Washington. Olympia always to Washington. LA always to California. In my vehicle number of wheels relation, or this is a function, it is an example of a function. Input of vehicle, output of how many wheels that vehicle has. This is again a completely predictable relationship and is therefore a function. Input of vehicle, asking how many wheels, always one on a unicycle. So input unicycle, output one wheel. Bicycle, we're going to assume that every bicycle has two wheels for this case. So input of bicycle, output is always two wheels. It's okay that both bicycles and motorcycles have two wheels. So two different inputs go to the same output. What's important is this predictable relationship between input and output. Input of bicycle, always output of two. Input of motorcycle, always output of two. Similarly, words and number of letters, when I have the input being the word, the function being how many letters are in this word, the output is always predictable. It is a function. I give you the word dog, input, output is always three letters. It's okay that dog and cat and box and cup all have 3 letters. The question is, given the input of dog, do I always get the same answer for number of letters? Yes. Some non-examples. We have fruit and color. We can assume that every cherry in the world is red, every strawberry red. So if that were the whole relation of fruit and color, then this would be a function. That would be okay. But moving on to apples, there are lots of different colors of apples. Some apples are red, some apples are yellow, some apples are green, and therefore the relationship represented in this table is not a function. Input of fruit, output representing what color that fruit is. So my function is what color is this fruit? When I input apple, sometimes I output red, sometimes I output yellow, sometimes I output green. So for the same input, apple, 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 I have more than one output. For months, we talked about how March, April, May, and June, if those were all the months, that would be a function. March always has 31 days. April always 30. May always 31. June always 30. But the month of February is what makes this relationship not a function. Input of February, output of how many days. Sometimes we have 28, sometimes we have 29. Not predictable, not a function. The vending machine representation is a very common way to think about a function. And we think, is this a vending machine that is broken, or is this a functioning vending machine? If the vending machine is broken, it is not a function. If the vending machine is good, what you would expect, then it is a function. So in this particular vending machine, we push C3, we get Cheetos. We push C4, we also get Cheetos. We push C5, we get Cheetos. That is a function. For the input of C3, I always get Cheetos. For the input of C4, I always get Cheetos. For the input of C5, I still get Cheetos, and that is okay. What is important, again, is this one single arrow leading from input to output. It is never the case that I push C3 and I get anything other than Cheetos. The very typical broken vending machine, broken function machine is right here. I put my money in, I push C3, sometimes I get Cheetos, sometimes I get Snickers, sometimes I get pretzels. There is not a predictable relationship between input and output. This is not a function. Similarly, the one down here where I push C5 and always get pretzels, that's great. It would still be a function if that were the only relationship within my vending machine. But here, C3 again is still broken. Cheetos, Snickers, not a function. Looking at some mathematical representations, another way to state my function definition, a relation in which each input has exactly one output, we could state that as a relation is not a function if any input corresponds to more than one output. So what we're looking for is the same x gives me more than one y. So this is the typical case right here. The same input x gives me different y's. This is not a function. 2 gives me 3, 2 gives me 1. Input of 2 does not give me a predictable outcome, a predictable output. 2 can have 2 different y values, not a function. Here, different inputs, 2, 3, 4. Each input has one output, definitely a function. This representation of ordered pairs is the typical kind of trick question. We have the same input more than once, -1, but we're just giving you some repeated information. -1 goes to 1, -1 goes to 1. The same input still has one output. -1 always goes to 1. Contrast to the second one, 4 sometimes goes to 5, sometimes goes to 10. Here we have the straightforward case. Actually, maybe not straightforward. This is really the important distinction. Do you understand the difference between these two? This is a function. 5 always goes to 9. 6 always goes to 9. 7 always goes to 9. For each input, there is exactly one output. Whereas for the second one, not a function, because sometimes 9 goes to 5, sometimes it goes to 6, sometimes it goes to 7. For one input, there is more than one output, not a function. Looking at our graphs, we have a yes. Bottom one is a yes. Each x has exactly one y. X equals 1, y equals 2, x equals 3, y equals 4. This point would be okay, 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 okay. It is these 2 points right here that make this not a function. We have x equal to 1, y equal to 1, as well as x equal to 1, y equal to -1, -4. So the same input, 1, gives me 2 different outputs, 1 and -4. Skipping that practice page, we have on page 13 the vertical line test, which is a way to think about whether a graph represents a function or not. So if you are able to draw a vertical line on the graph, and if that vertical line intersects the graph more than once, then it is not a function because it fails the vertical line test. For example, this is not a function, and I could draw my vertical line a lot of different places. You only have to draw one, but I could draw it many different places because for almost every point on the graph, if I were to draw a vertical line, it intersects the graph more than once. This is not a function. For this x value, there are 2 different y's, not a predictable output given the input. So there, I could draw it here. I could draw it anywhere to the right of that leftmost point. For this is x equals about 2. We have 2 different y values, not a function. Similarly, not a function, and the way we say this is it fails the vertical line test. It fails the vertical line test because if I draw a line right here, It intersects the graph an infinite number of times. Infinity is more than 1. So given an x value of 2, y can equal any real number. Y can equal a half, it can equal 2, it can equal 4, it can equal 4.5, it can equal negative 3.5. This is not a function. Given the input of 2, I have an infinite number of outputs. This is in contrast to my typical linear function pictured below. Every linear function is a function. Every line is a function other than a vertical line. So yes, any vertical line I were to draw here would only intersect the graph one time. This is a function because it does not fail the vertical line test, because it passes the vertical line test. Maybe you could say that. This relation is also a function. Every vertical line that I draw intersects the graph only one time. So there's only one y value for x equals negative 4, only one y value for x equals negative 3, for x equals negative 2, one y value, one output, x equals negative 1, x equals 0, x equals a half, x equals 2 1/3. Given any particular x, there is only one y, and that is visualized by saying any vertical line, which would represent a particular x value, intersects the graph only one time, therefore is a function.